and takes on the general form of this. Say, for example, for counter in sequence, sometimes it might not be a sequence. It might not be a sequence. It can be a vector. You can say vector of sequence. Let's say sequence. It doesn't necessarily mean numbers. It might be strings, dates, anything at all. So, for example, you have this kind of for loop. Say for I in 1 to 6. This is like a vector 1 to 6. Print I. So, what you're just telling this guy to do is print everything in this vector. For I in 1 to 6, print I. So for I in 1 to 6, that is for every values in that vector, print those values. So it's going to iterate it over it and print it one by one into the screen. So it checks when I is 1, it prints 1. When I is 2, it prints 2. When I is 3, it prints 3. Then prints 1, 2, 3, 4, 5 up to 6 in that manner. So let's see, for instance, for then inside a bracket, you put your condition for I in 1 to 6. And it says, okay, print I. And as you run this control enter, you can see 1, 2, 3, 4, 5, 6. This is a basic for loop, like a basic for loop statement. Now, I said you're writing something like this. I would advise you to use Grazes so that your code will be more readable. Like sometimes if you want to write complicated loops, doing this won't really make much sense. So if I want to do this again, I'll just, after this condition statement, this condition, I'll put a brace, then I'll click on enter. Then whatever I want it to do, I put it inside this place. So I say print I. I'm going to do this again after this and run it. Then you can see the results here. So this is a good way to write your code. Now, let's see whether we can get another example. Next slide, please. Is it not going? Okay. This one they have started talking about while loop. I don't want to talk about while loop now, so let me just. Can you guys hear me? Let me know if you can hear me. If you don't, yeah, okay, good. So look at this for loop now. We printed all the numbers from 1 to 6. You can put a condition to what you want it to print. Yeah, you can do that. Now, I can say, okay, I don't want to print all the numbers. Probably I just want to print the even numbers inside that sequence. So what am I going to do? So I'm going to put a condition. I will say if. And how do I know whether a number is an even number? It's going to be divisible by 2. So I'm going to say if I, if that value, for I in 1 to 6. So if I modulo 2, modulo is double percentage sign. I modulo 2 is 0. That is comparison. If this is equal to 0, what that means is that if I divide I by 2 and it has 0 remainder, then print I for me. Print I. So you have a conditional statement inside your for loop now. So this is not going to print 1 to 6 now. It's going to print 2, 4, and 6. Those are the even numbers between 1 and 6. So if I should run this command now, you can see it's only printed 2, 4, and 6. So you can do a lot more inside your for loop. So for I in this, do this, wherever. And as I said earlier, it's not only just sequence of numbers you can do it with. So let me create a list. Let me say a list. Let me say a list of say letters. Say A, B, and C. So I want to call this one to be A, B, and C. So let me run this. So this one has been created. So let's see what's inside this one. as you can see on my screen, ABC. So if I want to loop through this list one and I want to print everything one by one, what am I going to do? I'm just going to write a for loop and say for, I can say for alpha, you can write anything. It doesn't necessarily have to be I. For alpha in list one, so I want it to print all the alphas, that is all the guys in list one. So I will say print alpha. I should run this now and see it printed A, B, C. What is inside your list one, either it's one after the other in that manner. Now that's good. Now you can break your what's it called? You can create something like, maybe it's going to break the loop or something. You can do something like that. So how do I do something like that? I can say, okay, I can initialize a number, say J. I'll say J is 0. Then I can say, okay, then I'll say J is equal to, I'm going to explain this. J is equal to J plus 1. So I want my J to start from 1 anyways. I want to start from 1. So when I say J is equal to J plus 1, I will now put a condition. Say if J is greater than 2, I will now say, what do I want it to do? I want it to break. Okay, let me try this. I just got out this idea. I'm just doing this for the first time. Don't mind. So let me run this. So you can see this. It printed what? A and B only. You know what we wrote before was just one way thing. It was a little bit direct. But now with this, I'm saying that for alpha in list one, for all the elements we have in that list, print that element. Now I'm initializing a particular J. This is to like give a limit of what is going to print. So what I'm trying to do is that for every alpha it is printing, for every element you have in this list that is printing, your J is going to increase by 1. You know, the way it does it is like it's going over like one by one. What it does is that, okay, it checks alpha is A, prints A, then it goes back alpha in B to the next guy, it prints. So what's going to happen here, since J is 1, it goes for alpha in this, it checks A, then it prints A, then J is going to increase by 1. Now J is now going to be 2 at this stage, and it comes here. Is 2 greater than 2? No, 2 is not greater than 2, so it does not perform this operation. Then it goes back again. For alpha in list 1, that's the second guy is what? B. So it prints B, then it's increased J by 1. So J will now be what? 2 plus 1, that's 3. Are you with me? So it has printed B. Now it has printed A and B. So it checks. Since J is 3 now, it says if is 3 greater than 2, yes, 3 is greater than 2, then it was break. So it breaks the loop, then the loop is going to stop there. Then it's just going to print A and B. Instead of it to get to this C, it's not going to. So what this just means is that it's going to just print the first 2 guy in this list, because I've conditioned it to stop at 2. So whenever J is greater than 2, just stop the loop. So something like that is you're going to see something like that in while loop, but then it's more or less embedded in while loop, since your condition to break the loop is inside the while loop already. So let's see how this works out in the while loop. Do you have any question before we proceed? It's very essential for us to ask questions if you don't understand something, because these loops will be very important when you are dealing with things. You have to use it to perform some stuff, like even over through your data frames, check some condition and put some things in place. So now let me go to while loop and let's see how that works out very well. That's about for loop. Now the while loop is that it executes a set of commands repeatedly while the condition is true. As I said earlier, it does a particular task given that the condition evaluates to be true. So this is like a typical while loop statement. This is how you work. While condition, then task. So it checks, is this condition true? Then it does this part if it's yes. So for example, like say, as long as I'm the president of Nigeria, the minimum salary of workers is going to be maybe 50,000 naira. Now, as long as that condition is true, the minimum salary of workers is going to be 50,000 naira. But then, if I stop becoming, I stop to be the president of Nigeria, then that's my thing. But according to my statement, as long as I'm the president of Nigeria, the minimum wage of workers is going to be 50,000 naira. So it comes checking that condition can be over a period of 1 year, can be depending on the kind of counter you put in place, something depending on the kind of tax you're trying to do. So let's say, for instance, let's check whether we have an example here. This example is quite probably not. Uh, Very, it can be difficult to explain what they're trying to do here, but let's just look at something that's more explanatory. So, for example, now I'll use this instance again. I will now say, okay, uh, uh, now I will set a counter. Say J again. I'll say J is 1. Now I will now come here to say, while J is less than 5. While J is less than 5, print I love to code. I love to code. Now, if I should highlight this statement now from here to this place, who can tell me what's going to happen to my program? I need a suggestion. Who can tell me what is going to happen to my program? If I run this line of code that I've highlighted now, what's going to happen? Suggestion or answers? I need answers. Hello, am I the only one on this call?
If you highlight you've assigned 1 to J.
Okay.
Why J is less than 5, it should print. This one will be an infinite loop now.
Yes. Exactly. So this is going to print I love to code, I love to code, I love to code. And it wouldn't stop printing. And the reason is that J will always be less than 5 because I've assigned J to be 1. So when is it going to stop exactly? It's not going to stop. So that's the idea of doing something like this. What I just did here. That's the idea of doing something like that. So I can now increment J by any number I wish to implement it. So I will now come to this next one. I will now say J is J plus 1. I can implement it by 1, I can implement by 2, depending on what you are trying to do. So here now, if I should now highlight this code and run this now, so who can tell me how many times this is going to print I love to code?
Four times.
Yes, exactly, 4 times. Because when J is 1, it's going to print I love you. Then J is going to increase by 1 and become 2. When it is 2, it prints this. When it is 3, it prints. When it is 4, it prints this. But when J becomes 5, this condition will not evaluate to be true again. It's going to be false. So it's going to exit the loop and not going to do this. So it means J is going to be printed. Sorry, this string will be printed 4 times, at least in 4 places. Let's try and run that and see how this works out. If I should run this now, you can see I love to code, I love to code, I love to code, I love to code in 4 places. So that's the intuition of the while loop. So it's doing the particular task repeatedly as long as the condition evaluates true. So, but by the time the condition stops to be true, then it stops working, it stops performing that task. Then I can also do this. What I just did here, I can also do it inside this while loop. Say probably I don't want this I love you to print to a particular point. Maybe I don't want it to even get to 4. I can put an if statement that if that printed up to this amount, just stop the loop. I can do that. So coming to this guy here, so let's try and get it. Now in this illustration, they created a variable temp as null. They created another variable temp1 to be null. Now at this point, if I run this ls command, let's say we don't have any variable created in our work history, like in our environment before. So if it is a fresh session, a fresh environment, then it means if I run this ls command, I will have just these two objects in my work history, that's temp and temp1. Now again, I'm assigning j to be null. It means I've created 3 variables. Then I've assigned name to be temp. It means I've created like 4, like that now. Now if I should say while exist is a function that checks the existence of a particular thing. So while exist nm less, that is if nm is assigned to paste name, comma name is already temp, j, comma separator is but an empty string. What is j? J is null. So if I paste j, if I paste name, which is temp, a null value, it's still going to be temp. So since temp exists, it's going to be true, right? So it comes to this if else statement and check, is j null? J is actually null from instance. So since j is null, it's going to what? Assign j to be what? To be 1. So j is now 1 now. Then it goes back to this while statement. Does this guy exist? So what do we have now? Name. What's name? temp. What's j? J is now 1. If I paste temp and 1 together, I have temp1. Does temp1 exist? Yes, because I've already assigned temp1 to be null here. So it comes to this next statement and check, is j null? No, j is not null. J is now 1. So j is now 1. What does it do? It comes to this else statement and does what? J is what? J plus 1. So j is now increased to 2. Then it comes and checks this while statement again. Does name paste name and j together? Name is temp and j is now 2. So if I paste them together, I'll have temp2. Then it checks, does temp2 exist? No, it does not exist. Since it does not exist, it exits the loop. So that's what this guy is actually doing. So I think that's very understood. All right. Moving to the next slide. So I'll start following our command. X is 4, y is 2, z is x minus y. What is going to be the output, the correct output of the given command? It's going to be 2 because 4 minus 2 is 2, so z is going to be 2. I'm talking about R Hadoop, which is a combination of client-side R and Hadoop framework. So this is having to enable the integration of R and Hadoop together to leverage R on Hadoop, and that we can work on like it's just like scaling our scalability, because normally R is going to work in memory to access data in memory. So ability to leverage R and Hadoop will allow you to be able to access larger files, like to access files. Instead of working in memories, you can work with bigger data sets and leverage R on Hadoop. And also because Hadoop is written in Java, so and having to write a lot of MapReduce program in Java can be so burdensome on the analyst part, because not so many analysts can code in Java. So having to integrate R and Hadoop will allow you to write your own MapReduce program in Hadoop and do analysis instead of having to code hard-coded Java, write hard-coded Java to run your MapReduce program. You can create your own MapReduce program in R and do whatever you need to do. So, sorry, there's someone I need to allow me to the so the core functions include HDFS and MapReduce. That's for Hadoop. So having to embed our Hadoop, you'll be able to have access to these packages RMR2, which consists functions for integrating R and MapReduce, and RDFS, which is an interface that provides the file management functionality of Hadoop, and RHBase, which provides the database management functionalities to the HBase in the Hadoop ecosystem. So these are the major packages that we make use in our Hadoop. Now, you have to be able to do this, you have to use a virtual machine. So the steps to do that is in your lab manual. There are some packages that you have to install before you do this. There are some prerequisites you have to install. I think you should have them in this next slide. No, yeah. So here is just talking about how to create your own MapReduce function in R using R Hadoop. And sorry. Oh, they didn't show that. So in your manual, you are going to see your what's it called? Your book one. You are going to see the necessary requisite package you have to install for you to get this done. They didn't show it here anyway. Okay, so I said after installing the R-based package, the other package can be installed with their dependency. For example, okay. So all of these prerequisites that you need to install before you can start to install your R are inside your book. I thought they used to put it here, but I can't see it anymore. So here is having to create your own MapReduce function in R itself. So you can see they created a word count function. Say function is this is going to take in an input. This one is like trying to perform a word count, word count in R. And before we use MapReduce to do that, creating our Java class in Eclipse. But here we are doing it in R, create a word count function. This is going to require your user and your mapper class. Here, this is where you create your map class and your reduce class. These are being created in R. Then you call the MapReduce function in R. Then your mapper function that you have created is going to be your inputs for the map parameter, and your reduce function you have created is going to be your reduce function. This is not dynamic. Like you can create your own map and reduce function by yourself depending on the way you want it to it's not dynamic, it's customized. So how do you want it to work out? So it's you that is going to define that. So this is going to have your MapReduce function, then taking your input, your output. What's going to be the input format? Text, you are doing a word count. It counts each the words inside a particular text. Then you have your map and all of that. And you put a parameter combined to be true. After I've done this, I think that is all. I said Alex, the developer in ABC Data Analytics, needs to carry out which of the following function will this select to perform stacks. Talking about the MapReduce function in R, which is what they use here. Okay. I think that will be all for this session. That will be all for this session. I think there's a part in this module where they talk explicitly about loops. I'm not saying it. Okay, just that. But there's a lot you need to know about loops. There's a lot it can do. I think I don't know that I have some scripts here. So let me show you some scripts. This is okay. This is one function. This is one.
Yeah, Emmanuel.
Yes, can you hear me? I can hear you.
Yes. Does that mean we can move on with installing on our system?
You said
Does that mean I can move on to installing Naradu for my system?
you can do that on your virtual machine if you have the virtual machine installed on this.
Yes, I can't do it on my system, bro.
In a local system, you can't do it on local. So let me show you what is inside here.
See, this concept of Hadoop, I don't understand it at all.
So it's just having you to leverage R in Hadoop instead of having to use uh, write your MapReduce program in Java. It allows you to create your own MapReduce function, and it gives you the ability to access larger files because R works in memory. So it works in memory of your PC. So by the time you have larger data, you won't be able to work with them. Your systems won't be able to carry them. So leveraging R on big data, you have to integrate. So that brings about integrating R with Hadoop so that you can have access to work on the whole data set instead of having to just work with maybe a sample because as I said earlier, it's just how it works in memory. So the larger the file, then the more difficult it becomes to work on that data because it will be very difficult to do that because how it works in memory, as I said earlier. Do you understand?
Okay.
So in here, I created a while loop to do something for me. I created this while loop. You can see you have another while loop inside this while loop. It's and I have some values I initialized here. Some values I initialized here. J, K, and L, result, and all of that. So what is this guy trying to do for me? I have a set of zeros and ones. Say for example, let's say let me create repeat what is it called? Let me say repeat 1 4 times. Let me to repeat say 0 5 times. Say repeat 1 say 4 times again and repeat 0.
Are we still on?
Are we still on what?
Loop.
Yes, I just want to explain what I did here. This is a loop I wrote in R. So now look at this now. I have this result. I have this result of ones and zeros, ones and zeros. Now my challenge is that can I know the number of ones and zeros I have like in groups? Like this is the first ones I have. I have another set of ones. So if I do a group statement, I group this guy. I'm just going to have just 1 and 0 and the number of times they appear. But I want to say, okay, the first group of 1 I have is 4. And the second group of 1 I have 0 I have is 4. Then the next group of 1, 4. So this one is 5. And this one is 4. And this one is now 4. So I should have something like this as a result. Say 1, I have 4 ones, 5 zeros, 4 ones, and 4 zeros, something like this. So I know that okay, this one, the first set of ones I have in this maybe vector is 4, then the second set, and the first set of 0 is 5, next set of 1 is 4, like this. So if I should do a group by on this guy, normal group by, all it's just going to give me is, okay, it's going to tell me that, okay, the number of 1 there is 8, and the number of 0 there is 9. This is not what I want. This is not what I want. I want something like this. So to do that, it means for each set of 1s and 0s, I have to give them a unique, like, what's it called? A unique labeling. So these ones should have the same label. This set of 1s should have same label. Then this set of 0s should have another step label entirely. Then this another label. But the label of all these ones should be similar. So that's the challenge I have, and that's why I created this guy to help me solve the problem. Now here I'm saying that I'm creating a label 1 should have G1 underscore something, then label 0 should have G0 underscore something. So this is going to be the label for all the 1s, and this is going to be the label for all the 0s. So for the first set of 1, it may have something like G1 underscore 1. For the second set, G1 underscore 2, and so on and so forth. Then for 0s, the first set of 0s should have G0 underscore 1, the second set G0 underscore 2, and like that. And that leads to writing this whole loop, and it did that for me. So let's say, for example, so let me say I want to do this, I want to use this guy, I want to use this algorithm to label this, what is it called? This vector I just created. So let me give the vector a name. So this vector I just created, let me call it VEC. So I want this guy now. So that's created VEC at this set of 1s and 0s. Oh, sorry, VEC further. The VEC exists. So if I should work with this guy, so if I should work with this VEC, all I just need to do is to change this SAMP to VEC. I'll just replace SAMP with VEC, and it's going to perform all the wonders I need it to do. So VEC here, then VEC here also, then VEC here, then VEC, then VEC. Okay, so I think, okay, then the last one here, VEC. If I should run this now, I'm going to highlight it from the beginning to the last part. So let me run this loop now. Okay, it has run successfully. So first of all, let me show you what VEC is. This is our VEC. Now let me now show you the result I have after running this loop. I think the result is stored inside this variable called result. So if I should open result now, result, this is what you have. You can see I have the first set of 1 is what? 1, 2, 3, 4. So I have 1, 2, 3, and 4. Then next, the first set of 0s is 1, 2, 3, 4, 5. Then the next set is this. So it's easier for me to see now. See, I'll just say table of result. I'll just call the table function. I'll help him to aggregate that. So you can see, this one is telling me that the first set of 0 is 5. The next set of 0 is 4. The first set of 1 is 4. And the next set of 1 is 4. I've been able to solve my problem using that loop. So it's very, very interesting to know. So having talked about this, so let's just go to the next session. Do you have any question?
I don't understand it. I don't read the data.
You don't understand the loop, Abby?
Yes.
Yeah, I know you might not get the loop like this. So I'm recording this session. So this is what is inside the loop. So this is the beginning of the loop where I initialize date to be 1, and this is the ending of the loop. So you can, maybe in your leisure time, you can go over the recording and try to understand what the loop is trying to do. You can get it. I don't think we would have the time to talk about this because of our time. Or should we talk about it?
No, no, I'll go.
All
I'll go online.
all right. So maybe that's that. Okay. So yeah, the next thing we'll be talking about is graphical analysis in R. Strong the network. So yeah, what are the objectives we're going to be talking about? Hello.
Bye.
Okay, I thought someone called me. Okay. So we'll be talking about how to depict graphical analysis for single and multiple variables, how to implement graphical plots for multiple comparisons, special graphical plots using inbuilt R functions, and also steps to save graphics to files using R. Now, you have various types of plots. You have the plots with single variables, plots with multiple variables, and we have our special plots. Now, let's see those examples of plots. Now, plots with for single variable, we have the histogram, we have the index plot. The index plot is not really useful per se. We have the time series plot and we have the pie chart. Now, how does it work out? Now, histogram can be used to display the mode, the spread, and the symmetry of a set of data, and the hist function is used to what to plot histogram. So all these, the hist function is part of the base R package in R, that is the the traditional kind of function to plot, but we have more sophisticated package that you can use to build plots, which is more interesting than this base R package. So let's take an instance. Uh, okay, let me say I have let me come down here. Well, I didn't know I write some. Sorry, move back to this place. So here, graphical analysis in R. So yes, say I think I have the I data set already. So let me say I want to plot iris pattern. Okay, let me use the it function. It is um iris pattern. Let's say separate point. It's something like this. Because the reason why it's kind of short here is that the the frequency of the data is not really much, so that's why it's not. If you want to see a proper view of your histogram, you can plot your charts on a Windows screen. So you can use the Windows function, say 25 with a frame of 25,20. If I want this now, you have a frame pop up. So you have this frame. So any chart I want here, any plot I build here is going to be shown on this Windows. So I think it will make more, it will be more visible for you to see. So if I want this now, it's going to appear on this window. So you have something like this. So it's kind of bigger, like from just seeing it from this place. So I usually use this. Right. So this is how the plot is. So you can reduce your bin size, the number of grades you have, and all of that. So let's go back to the Now, looking at this, you can reduce your brain. Say histograms are tricky because what you see depends on the subjective judgment of where exactly to put the beam margins. White beams produce one picture, now beams produce a different picture. Compared to, look at this, if you look at this one has smaller beam compared to this, then compared to this. So this one, like they're giving it space for variables that are closer to each other.
No. Oh, okay.
Are you saying something? You can't see the screen. Hello?
Hi.
What did you say? You said you can't see my screen.
Yes, I can see it now.
Okay. Now, let me see. Let me go back to my R again. So let me see. Being with results. Alright. I have to see that in the plot function, not the histogram function, anyways. So yeah. So why isn't this function in R? The number of bars or the width of bars cannot be specified. So as you can see, Azure wasn't able to specify it in that function. That's the is function. So the choice of beam width is a compromise made between removing significant points and width. And this is the general rule for beam width. As the maximum minus minimum. Like, let's just forget about this one. There's a way how decides the beam width by itself. I think this is just the idea behind it, giving your own data set. But if you're using the plot function, you should need to specify the beam width. And this one is index plot. This one is index plot. So it's more like you want to do an histogram, but you don't want it in histogram format. You want it as point or something, but it doesn't really make much sense. Yeah, you have the time series plot, which is used to plot the time series data. You can use the plot function. You can use plot.ts function, which is used to specify to plot time series data. Let's say, for instance, uh, let me look for a data set, a time series data in R. So let me check. So data, let me check for a time series data set here. Volcano, no. Let me see. On this, I think this one is, yeah, is it? Let's be gets about this. Okay, I think this one is the time series data. So let me see this. USA secrets. There's a particular US target. Let me see this. This is a time series data. So US, yeah. Okay. So this is a time series data set. So if you want to check the class, you can say class of this type. It's TS, so telling you that the time series data. So I can use the plot function to plot it. If I should say plot this is what I'm going to have. The function of time. So now I can use plot.ts. I'm still going to have the same method. like this. So these are your time series plot. Basically, you can plot uh, you can plot multiple uh, data sets on a single plot. As you can see in this on this my screen, I have multiple lines in a single plot. So I said the two functions used for plotting time series data are ts.plot. You have ts.plot and plot.ts. Even your usual plot function also gives you the same result anyways. So also we have the pie chart. It's also a single variable plot. You can have a 3D pie chart also, but there's another package that you can use to do that. So you can have a pie chart also, as you can see here. So for example, let me see what there's an instance here. Okay, so let me create an instance. Uh, let me create a simple pie chart. We use uh, the pie function. Then let me plot. Let me give it a particular data x. Say this one is 15, 20, let's say 10 and 40 or 60. I just want to plot 4 of this. Then onto the labels. Label should be okay. All labels should I give it? Just give it A, B, C, and D. This one. Okay, so let's see. I'll give it a name if I like. So this is how it's going to look like. So so your A, B, C, and D correspond to the arrangement of your x's. So 15 is for A, 20 is for B, 10 is for C, and 60 is for D. As you can see that D is the largest there. So this is just a single pie chart. Now also you can now you have this strip chart, which is like this one is just like we are trying to plot categorical variable. It doesn't really make much sense. Like this data point for a categorical variable, say uh, um, say I have this column A to H, and this column A to H has corresponding values assigned to it. So A comma 2, A comma maybe 2.5, A comma 4, A comma 5, and it's just going to plot this something like this. So depending if this is kind of useful for you, you can do something like this. Now, then going to what we call plots with two variables. Now, before I go to this, I told you that there are sophisticated uh, uh, package that does visualization better in R compared to normal graphic package we have that is doing this plot for you. Say, look at this histogram. When did I do that? So this histogram, for example, that looks like this. If I can design this guy to be more, that is going to be something that's more interesting. Say for example, the X data sets. So before I do this, there's the name of the package is VGplot2. It's, if I load tidying part, it's going to come with this. I don't know whether it's even available or already loaded. I think it's already loaded, so let me just no, it is not loaded yet. So VGplot2. This is the package. It is VGplot GD means grammar of graphics. It can come out in your exam, grammar of graphics. So if I should load this, it's going to load the ggplot package. If I want to do some kind of nice chart, I'll do ggplots. Then what is the data I'm referencing? Iris. I'll say okay. Then what kind of chart am I trying to create? Histogram, film histogram. So what are the aesthetic? That is my what's it called? My X and Y, whatever it is. So I just need particular X, which is sepal.length. Sepal.length. Let's see how this goes. Let's see this. Look at the way it did its own. So it's break it into smaller bins compared to what we have before. Now I can do something like okay. I said using bins because you can pick better value with bin width. You can specify bin width. Now I can say okay, I want to plot this histogram for different categories. In the iris dataset, we have per sheet column which has 3 categories. Okay, I want to plot the sepal length for each category. I can say okay, do something like this for me. Can I do this? What if I include this preset wrap? We can read about this. So let me to build it against the spreadsheet column. I'm going to write something like this. So wrap the histogram depending on this particular column. If I should run this now, oh sorry, I didn't spell it very well. Spreadsheet. So let me run it again. As you can see here, the plot is now created per category. So for setosa, it's plus the sepal length. For versicolor, it's plus the sepal length, and for vesinica, it's plus the sepal length. I can also add color to it. I can say, okay, inside this geom histogram function, put fill. I will add the fill. Bits spreadsheet. I think I should do this. Okay, you didn't see that. Sorry. I think I have to put it inside this place. Okay. Okay. As you can see, it gave it different color depending on different category. Can make nice visuals using this. Sorry, please permit me for 5 minutes. I'll be back. I'll be right back. Sorry, excuse me. Just excuse me for 5 minutes. Please permit me. Hello, please. Sorry, I'm back. Sorry for the break. Yeah, yeah. Plot with two variables. In this case, you have your x and your y that you want to plot together. Talking about scatter plots and the likes. So here, say for example, you have scatter plots y against y against x, steep lines, box plot, bar plot, and the likes. Now, box and whisker plots might show like the distribution of the data. It make you see the 5 number summary, whether you have an outlier. It also makes you to identify outliers in the data set. So for why is this okay? No, no. Sorry, I think this network is just really bad. Okay, 13, 14. Okay. Okay. So this is scatter plot. This is scatter plots using the usual plots, whatever it is. So for example, I can also go back to here. So let's say I want to plot the sepal length against sepal width. I can use the plot function, automatically just helps you to do that. The plot is ampersand. Then we say total length, comma, total width. That is ampersand, total width. This is what I'm going to have. Actually, I'm going to have this. This is the scatter plot. I can change this style of this plot. I can change the style of this what's it called? The dots here. You know, this one I have like a circle and stuff like that. I can change the size. I really don't have them those parameters for my head. I think 6. I really don't. So is it CX? I really don't remember all of them. I don't know whether it's correct. Let me check. Oh, this is to increase the size. I just increase the size of the circles. So that's too much. Let me give it to be 0.5. Let me see how this looks like. You can see the dot has reduced. Now I can say, okay, I want to change the style. I don't want it to be circle, this small circle. What's the parameter again? So let me just look for help. I can't really remember all these parameters. So question mark dot. Let me just okay. Oh, okay. I really don't have anything. Wow, really. So there are also parameters to change the. I can't just remember the parameter. But you can have this one to be star. You can have it to be A. If I think my textbook is here, I would have seen it. So you can have it to be A. You can have it to be B. Any kind of shape you want this scatter plot to take, you can do that for you. So also, I can also use ggplot to do this. So let's say ggplot iris. I want to do scatter plot. I'll do zoom underscore line underscore point rather point. Then I'll put the aesthetic parameter, specify my x and my y. My x is going to be petal dot length. If I'm doing petal dot length, it is petal dot width. And my y is going to be petal dot width. Just change to the width. Then If I need to add some other things, I will add them. But for now, I just want to run this. If I should run this now, this is how it looks like for ggplot. I think it looks more finer. But okay, I can say, okay, I want to add color to this, but I want to change the color. I can say, okay, color is equal to red. But I can change that using the plot function too. I can do that too. Let me do this. So, until the color has been changed to red. Okay, now, okay, I want color. What if I want color to the spreadsheet? Spreadsheet. How does it look like? Oh, no. Sorry, I'm just put this inside. Color to this spreadsheet. So, how does it look like? Yeah, this is what I'm going to have. So you can see the scatter plot is now constructed according to the species column. So these points are for the Setosa category, these points are for the versicolor, and this is for Virginica. So you can see the plot of petal length against petal width relating to each category in the species column. There's a lot you can do. Now also we have the box plot. Okay, I think I have to go to the next slide. Yes, this is the parameter I was talking about. So this is the stuff I'm talking about. Each numbers represents each shapes you want the scatter plot to carry. Like number, what's it called? You can see this is the default. For 0, you have a square. For 1, you have 0. I think the default is 1. For 2, you have triangle. So if I put the parameter, if I specify that parameter and I put 2 as value, it's going to put the dot is going to be in form of a triangle. If I want in form of a plus, I put 3, but I think they have not specified the parameter yet. I have not seen the parameter. They said there are 256 different plotting symbols. So if I change, yes, the plotting symbol PCH, that's the name of the parameter, PCH. It didn't just come to my head, PCH. So if I come to this guy and I put PCH, let me increase the size of the point. Let me put 1 here. And I said PCH. I want it to be a plot. I think plot is 3. If I want this now, the class. If I want this now, nobody did. Yeah. Nobody went to class. So as you can see here now, the instead of having circle, I have plus. I have plus, as you can see here. So I can change it depending on what I want. So I think that's just it. Okay, so so you have over 200 plotting symbols, like 256 to be precise. So 0 to 255 represents a particular symbol. As you can see in this next page, 0 represents square, 1 represents circle, and the likes. So if I want it to be a times, I put 4 and the likes of that. And also, here, next slide. Oh, this one is just trying to create some kind of plot that this is not really necessary. This is just design everything. So this is just like a line chart you are trying to. So this circle you are seeing here are the actual points. All this one are just connecting these points with like a steep line. It's just more of a design. Sorry, please excuse me. All right. Sorry, I just have to. Now, adding other shapes to a plot. You have some functions to add shapes to your plot. All these functions work with like all these arrows and all of that. They work with like position. You can create squares depending on the position you want it to be. Like for example, the rect It's usually to plot rectangles, arrows, polygon, and the likes of that. So you just have to put the position and just do the drawing of the thing. So depending if you want all these things in your plots, you can do that. Um, Plot showing categorical explanatory variable. In this case, I talk about uh, the box plot. So the categorical variable refers to a variable that holds fixed possible values. For example, in human beings, say blood group type, blood group O, A, B, and the species variable in iris dataset contains categorical variables, three categories. That's special, color, Virginica, and all the rest. So you can create a bar plot, a box plot, using categorical variables. For example, I can say I want to know the number of categories I have in a species column. I can use the box plot to do that. Yeah, the bar plot rather. And the box plot works better with trying to see the distribution of the data set. Now let's see. Yeah. So this is an instance of a bar plot. Here we can see that for control we have like over 400 of them. For N25 we have like over 500. And this is going to see is going to summarize the categorical variables for you in that regard. Now you can use the box plot function to do that, like in normal graphical packaging. In this case, we use is for histogram. For box plot, we use for bar plot, we use bar plot function. So if I say I want to do for iris apart spreadsheet, it's just going to help me to do that. If I should run this now. So sorry, I think I didn't get this right. Sorry. Oh, sorry. Let's say I'm trying to plot a bar plot of actually say if it's species against iris apart there is let's take out for example. This one doesn't really make much sense for us. Now I can say okay, instead of this, I want to see the distribution of species. What's it called? The species column. I can say let me put the bar plot of this guy. This table is going to organize my species column for me. Then I pass into the bar plot function, and I have something like this. So this is telling me that Setosa has like 50 of Setosa in the species column. Then you have versicolor 50 of them, then Virginica 50, like equal distribution. I think the next in line is talking about the box plot. You can use let me see that box plot function. Let's say onto the distribution of the sepal or petal.length distribution. Let me run this now. I want to see something like this. I want to see something like this. So here, this first line, okay, probably I don't want to do this. Probably I want to see for all the numerical columns. So I think I can just do this. The numerical columns in the iris data set is from column 1 to column 3 to column 4. So let me just run this. This is going to be better. Now here you can see that I have 4 of them. So this is for sepal length, sepal width, petal length, and petal width. And this lower line here represent the minimum, and this guy here represent the maximum. Now this next line you can see here is your first quartile. Then this middle line is your second quartile, which is same thing as your median. Then this is your third quartile. I told you that this is the maximum. So now look at this. You can see in this second, what's it called? This second distribution, which is the sepal width. You can see there are some circles outside the box plot. So it means all these guys are outside the box plot, represent outliers. They are outliers. So it's allow you to see outliers in your, what's it called, in your data set. So for me to even see this, okay, I want to see this point. So I already seen that this guy is an outlier, sepal dot width. So let me just see what's the range of sepal dot width. Let me see 5 num. So I saw that there's an outlier in sepal dot width. But I say 5 num. I take 5 num function to see 5 numbers summary. Say iris percent sepal dot width. This sepal dot width. Let me check again. Take sepal dot width. Yeah. So this gives me the 5 numbers summary. As the minimum, the first quartile, the second quartile is the median, third quartile, and your maximum 4.4. So now what if I should now come here? Let's see. I want to see the range. If I type range of iris percent sepal dot width. So what does it tell me? This is going to give me the lowest value and the highest value. 20 corresponds to the minimum and 4.4 is the maximum. So these points are actually outliers. So this might not actually correlate to the maximum we have. It's just trying to say that these extra points, they are like larger, like extremely larger to the guy I can consider as my maximum, and this last guy is like extremely lower than the guy I can consider as my minimum. So to help us understand this, let's sort our sepal dot width column. So if I want to say sort iris percent sepal dot width, for example, look at what I have. Starting from here, I have 2.0. And look at this 2.2, 2.2, 2.3, and the likes of this. Now, coming back to this place, I have 4 point, then I have 4.1, 4.2, 4.4, and the likes like this. So if you go to your sepal dot width again, you can see you have this 1 point and this other 3 points. So it's considering this 2.0 as an outlier and these 3 other points as an outlier. And the reason is that if you look at this, all these guys are closely attached 2.2, 2.2, 2.3 before you get to 2.3 and all of that. But this one is just there. So it's considering this guy as an outlier, and whereby we have what's this called? 4.1, 4.1, 2, 4.4. Look at this. You have 3.8, 3.8, 3.8, 3.9, 3.9, then 4.0, then this is beginning to look different than what I've been seeing, because look at this 3.5 occurs so many times, then 3.6 occurs so many times. But all of this one just came and it just like increasing over time. So it's seeing them as an outlier in the data set. So for us to even better understand, let's create a sample data. Say VEC. So I'll use VEC again. Now VEC is going to have say 1, then I have 5, I have 10, Then I'll create something like, okay, 45, 50, 65. Then I have 99, 100, 55, say 45. Let me run this. Okay, now let me do box plot of this VEC. So let's see how this looks like. All right, this looks more mature. Okay, let me increase my VEC. Let me put let's see this number. Let me do it. So look at this. You can see there's a guy that is just outside the box. Like, this is the box plot. There's a guy that is just there. So it's actually this value 10,000. So you just look at this 10,000. It's extremely very different from these guys here. So it's identified that, oh, even though it's your maximum, but it's just out of this world. So it's seen as irregular kind of value. So that's why it's outside this box. It's identified as outlier. So box plus helps you to identify outliers in your data set. So having to talk about that, let's just move on also. I say you used to change the size of your computer window to 10,12. Which of the following has to change the screen size? No, I was using Windows function. Windows function helps you to create a Windows screen. Now, this one is different. This one is like changing the size of the computer window. That's talking about this part of your PC. So let's say, for example, window. Let's try it out. Window 15, 10. Let me try this. The error in Windows that cannot be that cannot be after end. Okay. What if I should put and window? Window is the only function which extracts the subset of. I don't think this is. I don't think this is what it means. I don't think this is what it means. It doesn't work out. Yeah. Okay, that's not it. It's an entirely different thing. I don't think this really makes sense at all. Oh, yeah, it doesn't make sense at all. So let's just proceed. I've talked about box plots, so this is already taken care of. Now the next thing is PS function, correlation plots, XY plots. You have already seen XY plot. Now PS function is like able to do it does a correlation, it builds a correlation matrix between two or more variables, numerical variables anyways. Say for example, I want to see how the numerical variables in iris correlate. Now the numerical variables in iris, that is the continuous variables or the numerical variables, let me just put numerical variables, how they correlate with each other. And the first four columns in iris dataset are the ones that are numerical. If I say pairs iris, give me for the first four variables. Let's see what's going to happen. Now you have this. So it gives you a plot, a correlation matrix, a plot whereby it does scatter plots of the four columns against each other. So this is separate against itself, so it doesn't give you a view per se, because it's just this is a perfect correlation anyway. So that's why this is like, this is a perfect correlation. Now, and this is the plot of separate length against separate width, separate length against petal length, separate length against petal width, and this second one is separate width against separate length, separate width against itself, separate width against petal length, and like that. So you have like 16. That's 4 against 4. That's 16 plots. All these ones are against each other, so that's why you have it to be in this format. Now, we also have the co-plot. The co-plot. CORPLOT. That's the correlation plot. If I do COR is going to build a correlation matrix for you. If I say iris for the first 4 guys, you're going to have something like this. This one builds a correlation matrix. So it calculates the correlation between 2 variables in whatever you specify. You know, I specify 4 columns, so 4 against 4. So this is separate length against itself, separate length against separate width. So it gives you values between 0 and 1. If it gives you a value of 0, it means those 2 variables you are plotting against each other does not have any correlation at all. If it is 1, it means they have a perfect correlation. But if it is near 0, it means okay, sorry, I think correlation value is between -1 to 1, not 0 and 1. -1 to 1. So if it is -1, it means it has a negative correlation, and if it is 1, it has a positive correlation. If it is 0, it means no correlation at all. Now, if it is near 1, we say it has a strong negative correlation. But if it is near, so if it is near -1, say it has a strong negative correlation. And if it is near 1, that is almost close to 1, we say it has a strong positive correlation. Now, when you have a correlation value of -1, what it means is that, so if I have x against y, say let's say, for example, this separate length against separate width. Now it has a correlation of -1. If your x is separate length and your y is separate width, it means that increase in separate length causes a decrease in separate width. That's the perfect negative correlation. That is, increase in separate length causes a decrease in separate width. But they have a perfect positive correlation. That is of value 1. It means increase in separate length causes an increase in separate width. So let's say, for example, let me give you an example of a strong positive correlation, or a positive correlation. Let me just put it that way. A positive correlation. It doesn't mean that to be perfect. It means that, so for example, if as rain is not falling like this now, umbrella is unlikely to sell. The weather is not really harsh. But as rain, the level of rain increase over time in a particular month, the sales of umbrella will start to increase. So you can say increase in rain causes increase in sales of umbrella. That's a positive kind of correlation. Now, a negative kind of correlation is that if something increases over time, it's going to cause a decrease in something. That's a negative correlation. So if something increases over time, then it's, so if x increases with time, then y is going to decrease. So that's a negative correlation. Now, we also have co-plot function. This is the best function as I think we have already seen, and we have the co-plot function. So this measures the relation between 2 variables. So the relationship between 2 variables may be obscured by the effect of other processes. When you draw, let's see how this works out. Let me see this co-plot. So this is still like a correlation plot. I can say, okay, plot. I want to create a formula, then the data is going to follow. Let's say I want to plot sepal dot width. Oh, sorry, not. I don't want to do it like this. First of all, sepal dot width against sepal dot length. Probably I want to include theta dot length. Should be able to do this. Length. Then I'm using the I data set. So I'll specify I and the data set, the data parameter to be I. Let's see. So there's something on. Am I missing on something? Probably I should put formula is equal to this. Okay, let's see. Error valid condition. Okay, let me run this. Probably I can't do this. So let's try this again. Wow. Wow. What's wrong? What's wrong? Output of type symbol is not substitutable. So let me check this again. Plots. Okay. You have yeah, this is it. I don't know why it's not accepting it. Is it? Yeah, I don't know why it's not accepting it. Why is this happening? Please. Sepal. Okay. Let me try this one more time. I really don't know why it's not taking my formula. But then let's proceed anyway. Let me see. Let me see. Okay. Let me go back to the previous slide. I think I'm seeing something here. I'm seeing another method here. I'm seeing a minus sign instead of this with sign. Let me try this. So sepal dot width not found. I really don't know why it's not taking it. Let's just move on. So this one is doing a plot of ozone against wind, I guess. Yeah, I can't even see the function that they use to create this. Probably we'll talk more about this in the next class because I can't get see the function used to create this, the data sets used. So let's just move on. We'll come back to this later. I think the next thing we'll be talking about the spatial plots. Why is this network slow? Okay, let me go back to why this network is concerned. In this book, like they use the ozone data. Yeah, they use the ozone data to create that plot, that correlation plot. Let me read it. Let me read it into the our environment. Ozone data is with, I think the txt file, table. It has an header, which is has an header, so header is equal to true. Since I don't know the location of that file, I'll just specify file.choose. I'll say file.choose so that it can help me pop up the file explorer, so I can just browse through. So I'll just run this, okay? Then I just have to browse through. So I'll go to where the data is. I think it should be on desktop. Let me enlarge this. So I have to go to desktop. Desktop. Is it on desktop? I don't think so. Let me go to documents. Let me see. Data sets here. I don't think so. I don't think so. So let me go to downloads. Sorry. Downloads. Data sets. Ozone.data.txt. That's the name of data. Let me enlarge this a little bit. Ozone.data.txt. Okay. I'm seeing ozone.txt here, but what's inside is like this ozone.data. Okay. Probably just that. Let me check the other folder. Let me check it. Ozone.data. Ozone.data.txt. Yeah, this is it. So let me load it. Open. Alright. So it's already in there. Now let me check what's inside. Head of ozone data. Okay, this is what we have. We have that, I don't know, I think maybe radian or something. We have temperature column, wind, and the ozone column also. It contains 111 observations, as you can see here in the variables. So they use this data to plot, use a correlation plot for that. So they did something like this. Plotted ozone, did something like this. TEMP panel is equal to panel dot tools. Now if I should do this, I'm going to have an error. Panel dot tools. If I just run this directly like this, I'm going to have an error. Reason being that this is not going to understand what I'm trying to create. Rather, so I have to specify that where am I picking my variables from? I'm picking from the ozone data the ozone data frame. So I've specified this. So it's going to know what is going to be here. Now, if you look at all these formulas that I'm using, you can, there's a table. I don't know whether it's inside this place. There's a table in your booklet. Let me check. That makes you understand this. Why I'm putting minus, then the bar sign. Let me accept this person before we continue. So there's a table that tells you what is, so probably, if I could remember very well, let me just try and skim through this thing so I can. Minus is kind of like, okay, I'm excluding the wind variable, then I think that bar sign, that's one I didn't really get rid of it. Let me just check. I think it should be there. I can't find it. are so many things I will talk about tomorrow. But you have to understand this minus and this plus sign. So if I should put a plus sign, if I put a plus sign like this, it means include. But this minus, I remember this means exclude, like exclude a colon. But this plus sign, I feel really, I still can get rid of it. So let's see how this one looks like. So object ozone of font. Object ozone of font. Wow, seriously. Okay, so let me just do it the way it is. So first of all, let me remove this. I'm going to attach the ozone data. I'm going to attach the ozone data now. So what do I mean by attach the ozone data? It means that uh, if I say I want to attach this guy now, it means that I can call the columns in this ozone data without having to reference this variable. So if I want to call the maybe rad column now, I can just type rad and you can see what is inside. Attach, oh sorry, ozone data. Around this. If I call rad now, it's going to tell me object not found. So it means I can't call the column explicitly. It's like, but I have to reference within the type I want to call this column. But if I use the attach, it means that now I'm
Sorry,
free.
why?
You said?
I can't see the screen. Is it
Wow.
myself?
You just joined the class. I don't know, probably just take maybe a minute or so. I think everybody else can see my screen.
I can't see it. So
Ah, you see. So let me check this again. I think it's the let me just share it again. Okay. I think I'm sharing my screen again. I think I'm sharing my screen again. Can you see my screen now? Hello, can you see my screen?
no,
How about now?
not yet.
Can you see it now? Can we can we see the screen now, please?
No, nothing from the screen.
Mm,
Oh, I think touching the screen depends on the fever.
what do you say?
Yeah, can we just continue? I think the one is
I don't know why you are not seeing my screen because it's really difficult. Please. You are still not seeing my, you are still not seeing my screen. This is it. Let me try it one more time. I really don't know why you're not seeing it. Okay, I'll try it again. Oh, but now can you see my screen now? You can see my screen, right?
No.
Right up.
I can't tell.
Hello, Ayola, are you there? Wow. Why is this happening now? You can't still see my screen. Sorry. Let me try and go out and
Let
go
us
back
wrap
into
up today. It's already 8.
Wow.
Maybe someone else spoke to you.
All right, no problem. I can hear you.